Yeah, welcome once again to my YouTube channel. So today we are going to look into an interesting topic in physics, which is motion. Now, what's motion? Motion simply means movement. That's in a layman's language. So what's the motion? It can be defined as a change in position of an object. If I move from a particular position to another position, motion is said to have taken place. We are going to study motion in two aspects: linear motion and the circular motion. So what's the linear motion and what is the circular motion? Linear motion is a motion of an object along a straight path. You see a student translating from his home to this very our tutorial. Such a student is said to have undergone linear motion. But when you see electron revolving around the nucleus, around that circular orbit, we say that circular motion has taken place. Hence, circular motion is a motion of an object around a circular path. Just like Earth revolving around the sun, that is circular motion. Now, the study of motion is termed mechanics. But under these very mechanics, we have two aspects of it, and we are going to look into one aspect. So the mechanics are classified into kinematics and the dynamics. Now, what's the difference between kinematics and the dynamics? Now, kinematics is the study of motion without considering the cause of the motion. Kinematics is the study of motion without considering the force that causes the motion, because we know that it is the force that brings about motion. So if you are studying motion without considering the force which brings about the motion, such aspect of motion is said to be kinematics. While dynamics is the study of motion with respect to the source or to the cause of the motion. Now we are going to study linear motion under kinematics. So we have linear motion. So under this linear motion, we are going to look into the terms of linear motion. The terms of linear motion. The terms of linear motion. Then we are going to look into distance, displacement, speed, velocity, acceleration, retardation. Now we start with the distance. Now what is distance? The distance is the journey made along a straight path. I repeat, distance is the journey made along a straight path. It can as well be put as the length of the path taken by an object. The distance is the length of the path taken by an object. Distance has a symbol s. Distance is a scalar quantity, meaning that distance has no direction. It has only magnitude. So whenever you are describing distance, the direction is not important. The only thing that is important there is the magnitude, which is the size. If I want to take distance of an object from a particular point A to another point, then moving from here to this point is the same as moving backward. Hence, distance is not in consideration of direction. Displacement is the next term there. Displacement is also represented with letter S. That shows that there is something that is common between distance and displacement, because both bear the same symbol. Now, displacement is a distance in a specified direction. Displacement is a distance in a specified direction. Now, displacement can as well be put as a journey made in a specified direction. Displacement is a vector quantity. It is a vector quantity because it is a distance that has direction. Like I told you, distance has no direction. Now, if distance should be attached with direction, automatically it becomes a displacement. Both distance and the displacement are measured in meter. Other units of distance and displacement, these are multiples of units. We have centimeter, kilometer, decimeter, but the SI unit, which is the standard international unit of both distance and displacement, is meter. A body that moves from here to this very point displaces in this very direction. While the distance is the path followed by the journey, the displacement is the short path moved from this point, let's say point A, to point B. Moving from point A to point B is not the same thing as moving from point B back to point A when it comes to what? Displacement. The reason is that the magnitude is measured from A to B or from B to A, which is the distance. But the direction moving from A to B and moving from B to A are not the same. Hence, they are not of the same displacement, but of the same distance. Then another term we are to look into is speed. Now, what's this speed? Speed is a distance per unit time. Distance per unit time. So speed can as well be defined as a rate of change of distance with respect to time. Written. Okay, it can be defined as the rate of change of speed or distance with respect to time. Now, from this distance, as we know, it's measured in meter, while time is measured in seconds. Hence, we have the unit of speed as what? Meter per second. Meter per second. Or in index form, meter per second. So any of these could be the unit of speed. Speed is a scalar quantity, meaning it has no direction. The next term there is velocity. Now, what's the velocity? Velocity is a displacement per unit time. Velocity can as well be defined as the rate of change of displacement per unit time. We have displacement measured in meter, while time is measured in seconds. Hence, the unit of velocity is meter per second. In index form, we have it as meter per second. Velocity is a vector quantity. It simply means that the velocity has a direction. Velocity can as well be seen as a speed that has direction. Both velocity and the speed have the same unit, the same dimension, the same symbol of representation. Now we are going to look into types of velocity. One, we have initial velocity. Then again, we have final velocity. We have average velocity. We have uniform velocity. And finally, we have instantaneous velocity. Now we are going to start with initial velocity. Now, initial velocity is denoted with small letter u. That's the symbol of initial velocity. Now, initial velocity can be defined as the velocity before the starting of observation. I repeat, initial velocity is the velocity of an object before the starting of observation. It is also measured in meter per second because it is what? A velocity. Then another one is final velocity. Now, final velocity is denoted with letter V. The final velocity can be defined as the velocity of a body at the end of observation. I repeat, final velocity is the velocity of a body at the end of observation. It has the same unit, dimension, and the symbol with velocity generally. Then another type of velocity is average velocity. Now, average velocity is denoted with V and subscript A. Now, the term average in mathematics, under a topic statistics, we encounter mean, the mean of an observation. So average and the mean, both of them are the same. Hence, we define average velocity as the mean of initial and the final velocity. I repeat, average velocity is the mean of initial and the final velocity. So we have average velocity as the what? Average, or the mean of initial and the final velocity. That gives what? A formula for calculating average velocity. Average velocity can as well be defined as the total distance covered in a given time. The average velocity can as well be defined as the total distance per time interval, as the total distance per unit time. So in that case, we still have average velocity as the total distance all over the total time. That gives another formula for average velocity. If you combine this equation, you will see a particular equation which is one of the equations of motion. Combining the two equations, you have total distance over total time equal to u plus v over 2. If you make the total distance the subject of the formula, you have u plus v over 2 times t. This is one of the equations of motion which we are going to encounter. Then, another aspect of velocity we are going to encounter during the process is uniform velocity. I hope you are through with this. Okay. So what's the uniform velocity? Uniform velocity, that's IV. Okay, let me get calculator. Okay, so right, the uniform velocity is a type of velocity in which the rate of change of displacement with time does not change. I repeat, uniform velocity is a type of velocity in which the rate of change of displacement with time remains constant. Now let's use an observation to illustrate uniform velocity. Now get the table of values. We have an observation, displacement, time. Now, this observation shows the displacement made at a given time. Now, let's see the rate of change of displacement with respect to time, which is velocity. Now, when the time changes from 0 to 1, the displacement changes from 0 to 2. When it changes from 1 to 2 seconds, remember, time is measured in seconds. Displacement is measured in meter. So, when the time changes from 1 second to 2 seconds, displacement changes from 2 meter to 4 meter. When the time changes from 2 meter to 4 meter, displacement changes from 4 meter to 8 meter, and so on and so forth. Now, to get the velocity, which is change in displacement all over change in time, the change in displacement over change in time. So, we have the velocity changing, displacement changing from 0 to 2. Then we have 2 minus 0, which is the change in displacement. Then the time changes from 0 to 1, that is 1 minus 0. So if you simplify this, we have 2 minus 0 is 2. 1 minus 0 is 1. 1 divided by 1 will give 2. Hence, distance over time, the unit becomes meter per second. Now, when displacement changes from 2 meter to 4 meter, time will change from 1 second to 2 seconds. Hence, we have the velocity, which is displacement over time. We have 4 minus 2 all over 2 minus 1. So we have 4 minus 2 gives 2, while 2 minus 1 gives 1. 2 divided by 1 gives 2. Hence, we have 2 meter per second. Now, when the displacement changes from 4 to 8, the time changes from 2 to 4 seconds. So, the velocity, which is displacement over time, now becomes 8 minus 4 over 4 minus 2. 8 minus 4 over 4 minus 2. Now, 8 minus 4 will give 4. 4 minus 2 will give 2. 4 divided by 2 will give 2 meter per second. Now, when velocity changes from 8 to 16, then we have change in the displacement changes from 8 to 16. Then we have change in this displacement, which will now be 16 minus 8. All over change in time, 8 minus 4. So 16 minus 8 will give 8, while 8 minus 4 will give 4. 8 divided by 4 will give 2 meter per second. Now, looking at this, you will observe that the changes here are uniform. Hence, we said that the velocity is uniform velocity. as the velocity all through is what? 2 meters per second. Then another type of velocity we have there is instantaneous velocity. Instantaneous velocity. So the instantaneous velocity is nothing but what? The velocity at a particular instant in time. Hence, the velocity at a particular point is said to be what? Instantaneous velocity. So if a body moves from one point to another, at that particular point you want to refer to, the velocity at that very point is said to be what? Instantaneous velocity. Then we are going to solve some exercises to at least understand this velocity well. Now let's get to the exercise. The very first exercise there says, exercise 1. A body traveled 20 meters to the right in 4 seconds, and then 12 meters to the left in 3 seconds. For each total motion, what was its average speed and its average velocity? Now we have this very question. Now to solve this, you write down the parameters. Remember, we are asked to find average speed and average velocity, 2 questions at a time. So solution to the question, a body traveled 20 meters to the right. So we have the body traveling 20 meters to the right. This is the right direction in a time 4 seconds. And then 12 meters to the left in 3 seconds. It now travels 12 meters in 3 seconds. Now you see the direction I gave here. Moving towards the right, I might assign it positive. Then moving towards the left, I might assign it what? Negative. Now looking at this, the direction is so important because we are dealing with velocity, which is displacement over time. But if we are dealing with speed, the direction is not important because speed is a scalar quantity. We are not interested with direction. But for velocity, we are interested in it. Now, the very first exercise, which is average speed. Now, average speed is the total distance over total time. Now here, our total distance is 20 plus 12. We are not interested with the sign, that is direction. Then all over total time. The total time is 4 seconds plus 3 seconds. So here the average speed now becomes 20 plus 12, which will give 32. 4 plus 3 will give 7. Now 32 divided by 7. Now punch your calculator. So 32 divided by 7. So punch the calculator and let me know what you get. So what do you get? Yes, 4.57. So we have this as the average speed. But coming to average velocity, so here we are interested with the direction. So we have to work with the total distance all over total time, total displacement all over total time. And the displacement, we now have to consider the direction. For 20, the direction of displacement is plus 20, while the direction of 12 is minus 12. So the total distance, total displacement becomes 20 plus minus 12 all over total time, which is 4 plus 3. So at this point, we are going to get average velocity as 20 plus minus 12 we give minus 12, right? So we have minus 12 all over 4 plus 3 gives 7. Now 20 minus 12 we give 8 divided by 7. Now 8 divided by 7. So punch your calculator. Yes, if you do it well, you are going to get 1.14 meter per second. Please note the unit. Average speed is measured in meter per second. Now let's take another exercise. So as you can see from the one we solved, the velocity and the speed, we didn't get the same value, telling you that what? They are not of the same thing. Okay. So we have another exercise, exercise 2. Now a ball is dropped from a height of 20 meters above the ground. It hits the ground in 2 seconds and bounces back up to a height of 12.7 meters in 1.6 seconds. What are its average velocity? Now we work on this. So solution to the question, we are asked to find the average velocity. Now a ball is dropped from a height. Now the ball is dropped from this very height of 20 meters above the ground. Now it hits the ground in 2 seconds. So the time is now 2 seconds. And bounces back up to a height of 12.7 meters. So it bounces back up to a height of what? 12 meter. 12.7 meter. In a time 1.6 seconds. Now, what are its average velocity? So the average velocity, we have the total distance over total time. Now we have to consider the direction. If we take the downward motion to be positive, then the backward motion, which is the upward motion, now becomes what? Negative. Because we are working with average velocity, velocity has a direction. So we have considered this very direction. So the total distance will now be plus 20, then plus minus 12.7, all divided by the total time. 2 seconds plus 1.6. Now we have to simplify this. Now 20 plus minus is what? Is minus 12.7 divided by 2 plus 1.6, 3.6. Therefore, average velocity now becomes 20 minus 12.7. And we are going to get 7.3 divided by 3.6. Now, use your calculator. So 7.3 divided by 3.6. So if you divide it well, you are going to get 2.03 meter per second. Now we are going to look into acceleration as another term of motion. We've worked on velocity, we've worked on displacement, distance. So now we are to move into acceleration. Okay. Okay, so what's this acceleration? The acceleration can be defined right. Acceleration can be defined as the rate of change of velocity with respect to time. I repeat, acceleration is the rate of change of velocity with respect to time. You can just put it as the change in velocity per unit time. So acceleration mathematically with symbol A is the change in velocity all over change in time. Where change in velocity, the change in velocity will now be final velocity minus initial velocity. Then, when time of a body moves from 0 to t, then we have change in time, in that case, to be equal to t minus 0. And t minus 0 will give you t. Therefore, acceleration A will now be equal to V minus U over T. So at this point, U is what? Initial velocity in meter per second. V is what? Final velocity in meter per second. T is what? Time in seconds. While A is the acceleration in meter per second squared. Yes, acceleration is meter per second. Why? Because if you divide the unit of velocity, which is what? Meter per second, by the unit of time, which is second, you are going to get what? Meter per second squared. Or you write it in index form in this very way. So this is the unit of what? Acceleration. Now, acceleration is a vector quantity, which simply means it has magnitude and as well as direction. So whenever you are representing acceleration, always remember to include the direction. It's very important. Okay. Okay. So having got definition of acceleration, there are terms I would like you to observe. But before that, let's look into uniform acceleration. The uniform acceleration So what is the uniform acceleration? You write. Right. Uniform acceleration. Are you there? Uniform acceleration is a type of acceleration in which the change of velocity with respect to time remains constant. Is a type of acceleration in which the rate of change of velocity with respect to time does not change. Now another one is retardation. Retardation is a negative acceleration. Okay, right. Retardation is a rate of decreasing of velocity with respect to time. Retardation is the rate of decreasing velocity with respect to time. So retardation is the decreasing velocity. That's a negative change in velocity over time interval. So retardation is also known as deceleration. Retardation is a negative acceleration. When the velocity is changing positively with respect to time, we term it acceleration. But when the velocity is changing negatively with respect to time, then we term it what? Retardation. So retardation and the acceleration, both of them have the same unit as meter per second squared. And both of them are vector quantity because both have what? Direction. So retardation is different from acceleration such that it has what? A negative value. So whenever you solve an exercise, you see a negative value with respect to acceleration, it shows that what? That the body is decreasing in its velocity. Are we there? Then let's also see uniform retardation. Uniform retardation. So what's the meaning of uniform retardation? Now write. Uniform retardation is a type of retardation. Uniform retardation is a type of retardation in which the rate of decreasing of velocity with time does not change, or simply said, it remains constant. Now, there are things I would like you to note. That's the note tabella. Please note this. Number one, right. When a body, continue. When a body starts moving from rest, its initial velocity becomes zero. When a body starts moving from rest, its initial velocity becomes zero. So initial velocity is 0 meters per second. Whenever you hear that a body starts from rest, hence from rest position, the initial velocity is 0. Then number two, when a body is brought to rest, right? When a body is brought to rest by the application of brakes, its final velocity is 0. Its final velocity is 0. So whenever you are told that a body returns to rest or a body comes to rest by application of brake, the final velocity of that motion becomes 0. But when a body starts from rest or begins from rest, its initial velocity is 0. But when it comes to rest, final velocity is what? 0. Then number three, right. When the velocity of a moving object, decreases, its acceleration becomes negative. I repeat, when the velocity of a moving object decreases, its acceleration becomes negative. So acceleration is negative when the velocity decreases. Then number four, right. The negative velocity is called, negative acceleration is called retardation. I said number four, the negative acceleration is called retardation. Do you have a question? Okay. Yes, it is called retardation. That's the negative acceleration. So retardation and deceleration is the same thing. So when a body decelerates, that is retardation. Okay, number 5. Right. When a body is moving with a uniform velocity, I repeat, when a body is moving with a uniform velocity, its acceleration is 0. Its acceleration is 0. So whenever a body moves with uniform velocity, that means that the velocity is constant. So once there is no change in velocity, acceleration will be 0, because we know that acceleration is the change in velocity with respect to time. So once there is no change in velocity, the acceleration automatically becomes 0. Now let's do some calculations on acceleration. Okay, take this exercise. Exercise 1. An object is moving at 15 meters per second to the right. After 8 seconds, later, it is moving at 5 meters per second to the right. Then, what was the acceleration of the object? Now let's look into this question. An object is moving at 15 meters per second to the right. That's the initial velocity of the motion of the object. After 8 seconds later, that is after the change, the time interval, after 8 seconds later, it is moving at 5 meters per second to the right. That same direction. 5 meters per second, which means it has decreased in its velocity from 15 meters per second to 5 meters per second. Then what was the acceleration of the object? So solution. Now initial velocity of the motion is 15 meters per second to the right. Hence we are now taking 15 plus. That's the direction now. Then after 8 seconds, that's the time interval, it is moving at 5 meters per second. So finally, it changes velocity, 5 meters per second, to that same direction, which means that same what? Direction. So plus shows that same direction. If of different direction, then it will now be minus. Then what was the acceleration? Now the formula of acceleration is A equal to change in velocity all over time. Then if you do the substitution there, acceleration, final velocity we have 5, minus initial velocity, we have 15. All over time interval, we have 8. So if we simplify this, we have 5 minus 15. We have minus 10 divided by 8. Now, if you divide minus 10 by 8, then we are going to have what? Punch the calculator. Okay, yeah. So minus 2.5 meter per second squared. 2.5 meter per second squared. Now that minus shows that what? It is retardation. Hence you may say that retardation, which is the negative A, is equal to 2.5 meter per second. Now let's take another exercise. So exercise 2, a car brakes and slows down from 20 meter per second to 5 meter per second in 3 seconds. Find the acceleration. Find the acceleration. Find the acceleration. Okay, so solution to the question: a car brakes and slows down from 20 meter per second to 5 meter per second. So initially, the velocity of the car is 20 meter per second. Then it brakes and slows down with a velocity now 5 meter per second in 3 seconds. So the time now is 3 seconds. Now find the acceleration. So here, acceleration is change in velocity over change in time. So we have acceleration. Final velocity is 5 minus initial velocity is 20 all over time. 5 minus 20, we are going to have minus 15 over 3. So minus 15 divided by 3, we are going to get minus 5 meter per second squared. And that gives what? Acceleration. Negative acceleration. Hence we term it what? Retardation. Are we there? So let's take another exercise. Now we have exercise 3. So it reads, a car travels at 10 meter per second and increases its velocity to 30 meter per second in 10 seconds. Find the acceleration of the car. Find the acceleration of the car. So solution: a car travels at 10 meter per second That should be the initial velocity. U equal to 10 meter per second. Now increases its velocity to 30 meter per second. Finally, the velocity is what? 30 meter per second in a time of 10 seconds. So the time taken for the change is 10. So find the acceleration. Now acceleration is change in velocity all over change in time. So at this point we have A equals final velocity is 30, initial velocity is 10, all over time interval is 10. So here acceleration is 30 minus 10, which will be 20, divided by 10. It will give us 2 meter per second squared. Now let's take another exercise. I hope you are getting the whole thing. If you have a question, feel free to ask. So let's take more exercises so it will help you to master the topic well. So exercise 4. Okay, so it reads, a car travels at 45 meters per second and decelerates its uniform velocity to 20 meters per second in 5 seconds. Find acceleration. Okay, let's solve this together. Solution. A car travels 4 meters per second. That should be initial velocity, right? So we have U equal to 45 meters per second. And decelerates each uniform velocity to 20 meters per second. So 20 meters per second is the final velocity. In a time, 5 seconds. Then find the acceleration. So with this, we have the formula acceleration, change in velocity over time. Here we have the final velocity given as 20, initial velocity given as 45, and the time interval given as 5. So acceleration becomes 20 minus 45 minus 25 divided by 5. If you divide this, you are going to have minus 5 meters per second squared. Okay. So I believe you are getting the whole gist. Now, we are going to look into graph, the graph of motion. The graph of motion. Now, let's treat it under a topic, position time graph. The position time graph. Please write down this, write it down, very important. I will dictate. Displacement, velocity, acceleration, all can be represented on a graph. I repeat, displacement, velocity, acceleration, all can be represented on a graph. Now the graph which shows the distance or displacement against time is called distance or displacement time graph. I repeat, the graph which shows the distance or displacement against time is called distance or displacement time graph. So we are moving into displacement time graph. Displacement time graph. Okay, right. Displacement time graph. Right. Displacement time graph can be defined. Displacement time graph can be defined as a graph which shows displacement versus time, which shows displacement versus time. So any graph that shows displacement versus time is said to be a displacement time graph. So with this, if we have a graph, the vertical axis represents what? The displacement, right? Or the distance. Then any graph that runs from here is a graph of what? Displacement against what? Against time. So that shows what? The graph of what? Displacement. So displacement is seen along the vertical axis, while time is seen along the horizontal axis. So here is the origin. Okay. Now take this. Are we there? Take this. Just write it down as a nota bene. The things you should note. Number one, the things you should note whenever you are dealing with displacement time graph. Number one, the graph which shows the velocity against time is called velocity time graph. While the one that shows displacement time graph is called, are we there? Is called velocity time graph. I repeat, the graph that shows displacement against time is called velocity time graph. Velocity, is called velocity. Are we there? Because displacement against time is velocity already. So any graph that has displacement against time is velocity. But the one with velocity against time should be acceleration, so not velocity. So here, any graph that shows displacement against time is what? Is velocity graph, or you call it displacement time graph. Are we there? Okay, 2. The slope of the graph represents the speed or the velocity of the body. This is the slope. So this slope represents what? The speed or the velocity of the body. Are we there? Okay, number 3. The horizontal lines written, show that the object is stationary. The horizontal line, if you have a slope like this, the graph of displacement against time, if you have it in this very way, if the slope is horizontal, it shows that what? If the slope is horizontal, what does that show? It shows that the object is stationary or at rest for a certain period of time. That means there is no displacement. The body remains at this very point. As the time is changing, the body does not change, but the time is changing. You see, it does not increase or decrease. So there is no displacement. While the time changes, the body remains at a position, which means there is no change in position. Okay. Now let's look into velocity time graph. Velocity time graph. So the velocity time graph. Are you there? Now, right. I hope you are getting what I'm saying. The way you are just moping at me. Please ask question if you have any question. Okay. So let's get the definition of velocity time graph. Like I said, velocity time graph can be defined. The velocity time graph can be defined as the graph which shows the velocity against time. Is a graph which shows velocity against time. The slope of velocity time graph is called acceleration. The slope of velocity time graph is called acceleration. While the slope of displacement time graph is called, okay? It's already in your notes. It's called what? It's called velocity. This is velocity. Are we there? Okay. So when we have a graph like this, here we have velocity against time. Here is y-axis, right? So we have velocity against time. So any velocity, or maybe we have a slope here, that slope shows what? Velocity. It shows acceleration. Okay. Now let's understand this velocity time graph well. Okay. Now write down this. Put it down. Consider a body, just take it down. Consider a body that starts moving from rest. That starts moving from rest and accelerated uniformly with a velocity v. After a time t1, it then moved with this velocity for time t2. It then moved with this velocity for time t2 before uniformly retarded to a stop. Before uniformly retarded to a stop after another time t3. Represents the information using velocity time graph. Now, if you go through the something you've written, you have a velocity against time. Here is velocity measured in meter per second. Here is time measured in seconds. Now here is the origin, which is what? The rest position. Now from what they said, a body starts moving from rest. Now the body starts moving from rest. Here we have what? Acceleration. Here we have what? Acceleration. Let me just, maybe to this very point, at a time t1, so the velocity of this body changes until it gets to this very point, which is what? The point at which it accelerated to. It then moved with this velocity for time t2. Now it moves with this velocity for time t2. So it moves with this velocity. No change in velocity. The velocity remains the same. No change. At this very point, we don't have acceleration because there is no change in velocity. You know, acceleration is the change in velocity with time. So there is no acceleration here. So here is uniform velocity. Uniform velocity. And you know, uniform velocity, acceleration is equal to 0. Then, before uniformly retarded to a stop after another time. Now, uniformly, it retarded to a stop at time t3. So, this is a graph representing the information. Now, there are a lot of deductions you can get here. Graphically, you can calculate the acceleration. You can get what? Retardation. Then, you may as well be asked to find the total distance of the journey. Now, the total distance of the journey is the area covered by the body during the motion. And looking at this now, if you check this, you will observe that this is trapezium. Opposite sides are parallel. So the formula for trapezium is what? Is half sum of parallel sides times height. So if you are to get the distance here, the distance should be what? Area of this trapezium, which is what? Half sum of parallel sides. Gives you the total distance of the journey. Okay, let's look into some exercise. So remember I said the total distance depends on the what? On the area. The area of the graph. Okay, let's look into this very exercise. Okay, so let's tackle some exercises here. But I remember the formulas of acceleration. Of course, you can just use the graph. You can just observe the graph and solve whatever thing that was given to you. Okay? So, this is retardation, please. Recall, here is what? Retardation, right? That's the negative acceleration. So, let's get the exercise. Exercise 1. A car travels with uniform velocity A car travels with uniform velocity of 30 meters per second for 5 seconds, and then comes to rest 10 seconds with uniform deceleration. Then I draw a velocity time graph. Of the motion. Then I find the total distance. Traveled. Then I find the average velocity. Okay. So let's look into the solving now. So the question says that a car travels with uniform velocity of 30 meters per second for 5 seconds and then comes to rest 30 seconds with uniform deceleration. So to get the graph, solution, that's solution I. Now a car travels with uniform velocity. Then we have this. Here is the origin. Here is velocity. Velocity of 30 meters per second for 5 seconds. So the velocity, initial velocity is not 0. And here is what? Origin. Maybe we get to a point here as the velocity is 30 meters per second. Now for 5 seconds, remember it travels with uniform velocity. So for 5 seconds, so it travels from here to this very point to 5 in a 5 second, right? So this is uniform. That is no change. It maintains 30 meters per second in 5 seconds. And then comes to rest 30 seconds with uniform deceleration. So it now retards. This is uniform retardation. In the next 10 seconds, so here is time. So in the next 10 seconds, initially it has covered 5 seconds. So in the next 10 seconds should now be 5 seconds of which it has covered before plus that 10 seconds, giving us what? 15 seconds. Now that's a graph, the velocity time graph. Now the second exercise says find the total distance. So solution I. Now the total distance is the area of this shape. Now you can work it in this way. Here is rectangle, here is triangle. You get area of rectangle plus area of triangle. You sum it up. Or because the two opposite sides are parallel, then you make use of what? Area of trapezium. Now this, when taken as a trapezium, the opposite sides are parallel. Hence, you work with the formula. Now, in order to get the total distance, which is S, is equal to area of trapezium, because the shape of that is what? Is a trapezium shape. And the area of trapezium is half sum of parallel sides, then times height. Half sum of parallel side times height. Now we are going to look into the sides that are parallel to each other. Now these are parallel to this. Now let's take this. Here is 0. This point is 5. So from 0 to 5, here is 5. The length here is 5 units. Then here is 0 to this point, 15. So from here to here is what? Is 15 by length. So the parallel sides, we have 5. We have 15. So the parallel sides, sum of 5 and the 15. Then times height. Now the sides, these two sides are parallel. Then we consider the height. So the height now should be 30. From here to here is 30. 30 meters per second. So we have 30. So at this point, we have half. 5 plus 15 gives 20. Then times 30. Now, half of 20 will give 10. 10 times 30. Then we are going to have what? 300 meters. And that gives what? The total distance. Then the next exercise there, we are asked to find the average velocity. Then you remember, average velocity has two formulas. We have u plus v over 2. Also, we have total distance over total time. So, the third exercise, average velocity. So, average velocity here, we work with total distance because we've got the total distance. So, the total distance, 300 over total time. The total time is from 0 to 15 seconds. So, the total time should now be what? 15 seconds. So, if you divide this, 15 here, 1, 15 here, 2. So, we have 20 meter per second. That gives what? Average velocity. So, let's look into another exercise, maybe before we conclude. Okay. So we have another exercise. So it reads, are we there? A car starts from rest. A car starts from rest and accelerated uniformly at a rate of 4 meters per second for 5 seconds. It maintains a constant speed for 20 seconds. Brakes applied and the car stops. In the next 3 seconds. Then find